final speaker is Dr. Andrew Woods. He is an associate professor manager of the Hive visualization facility.
Thank you, Takashi. All right, so I'm talking about passive polarized 3D TVs, and from 2007 until 2016, a huge number of 3D TVs were sold into the consumer market via a multitude of different manufacturers. There was a big push for generating 3D content to support 3D displays. Hundreds of different 3D TV models were manufactured, and millions upon millions of 3D TVs were sold into people's homes. And multiple display technologies were used, OLED, LCD, and plasma. There was also rear projection DLP, DLP projection as well. OLED's organic light emitting diode, LCD is liquid crystal display. And they also use different types of 3D display, whether it was active 3D with shutter glasses or passive 3D using usually circular polarized glasses. They produced big, bright and high resolution displays. There was plentiful supply and affordable prices. And then we hit a cliff. 2017, there were no new 3D TV models announced as part of manufacturers' releases. So 2016 was the very last year that 3D TVs were manufactured and sold on a massive basis by the mainstream manufacturers. Now, 3D display does still remain a requirement for many consumer and commercial applications. There's still interest in 3D display. 3D Blu-ray discs still sell in the consumer market. Now, 3D projectors do remain available, new and in the market, but there's just no new 3D TVs in the consumer market. Now, a little bit of background about the facility that I manage, the Hive Visualization Facility. The Hive stands for the Hub for Immersive Visualization and E-Research. And it's both a physical facility, and in that space we've got 4 large screen display systems. 2 of them are stereoscopic. The one on the left at the moment is the cylinder display, which uses active 3D glasses. The one in the center of the display now is our wedge display, which is 2 rear projected panels. That's also in 3D using shutter glasses. And we've got 3D TVs, and we've got head-mount displays, which are 3D as well. So 3D is a very core part of our the operation of our facility. Many of the projects that we support actively use stereo. This is a project that we conducted in 2015 and resulted in a museum exhibition that's currently running at the Shipwreck Museum in Fremantle in Western Australia, which is just on the outskirts of Perth. And it's an exhibition called Deep Light. And in the middle of the exhibition is a little theaterette, and in there is an 84-inch passive 3D TV showing a short 3D film called From Great Depths, which was produced from 3D video footage that we captured during the expedition, the survey of the 2 shipwrecks. So the exhibition is about 2 shipwrecks, the HMAS Sydney and the German vessel Cormoran, which encountered each other off the coast of Western Australia in World War II in 1941. At the entry of the exhibition is a visitor book, and let's just have a look at that visitor book. We can see some of the comments here. 3D movie, absolutely beautiful. 3D movie was haunting, beautiful and informative. Very moving 3D movie, wonderful. I loved the 3D movie, was very real, and so on. And throughout the book, there's constantly comments about the 3D content that's used in that exhibition. So there's obviously continued interest, and it has impact. So there is continued need for these kind of devices. But with 3D displays not being sold in the consumer market at the moment, 3D TVs at least, that presents a limitation. Now, a little bit of background about one of the displays that are used, and the one that we've been mainly using. The LG and a few other manufacturers used a technique called spatially multiplex polarization, also known as micropole, or using a micropolarizer array. LG used the term film patterned retarder, FPR, and they sold their displays under the brand Cinema 3D. And it was called Cinema 3D because they used the same glasses, the same circularly polarized glasses as Real D did use in their theaters, as does Depth Q. So in that technique, alternate rows of the display are polarized with a different polarization, usually implemented with circular. The first paper I'm aware of which presented on this technique was presented by Sadiq Faris in 1994 in the Stereoscopic Displays and Applications Conference. The fifth ever SD&A conference was where this was presented, and there was a paper titled Novel 3D Stereoscopic Imaging Technology. Here's a little diagram on the side here which shows the micropolarizer array that's fitted to the front of the LCD panel. The LCD panel has alternate rows of the LCD being shown with left and right content, and the micropolarizer array has alternating strips of the two different alignments of polarization, such that all the left pixels have one orientation of polarization which matches the polarization in the left eye. Now this is being shown as linear polarization here, but again, most of it was circular. So the advantage of this technique is that it uses passive glasses, which are lightweight, comfortable, and inexpensive. You can buy them at the theatre for $1 each, and it's very easy to equip a large audience with lots of glasses. It does, however, suffer from the problem that it has half vertical resolution of the panel going to each eye. Yeah, so you will get half vertical resolution depending upon what panel resolution you're using. In 2012, LG started releasing 4K resolution Cinema 3D displays. And in 2016, their entire lineup of 3D TVs were all 4K, which means that if you are recording and displaying full high definition content, you would be able to get the full resolution of that content on this particular type of display, because the vertical resolution in a 4K display, when you divide that by 2, that's the same vertical resolution as a full HD content. Now, the horizontal resolution is full 4K, or the consumer version of it, 3860, I think it is, 3840 was it? So you can get more than full HD if you've recorded your content in a higher resolution. But so a 4K display is very good for being able to display full HD content, at least in full HD, full resolution. Now, over this period from 2012 till 2016, LG released a large number of 4K resolution passive 3D TVs, and these are all the model numbers and sizes of those. Both LCD and OLED were released. The USA model numbers are what are listed here, and the model number just slightly changed, perhaps in the last 1 or 2 digits in other regions. There were 51 different models in 9 different panel sizes, ranging from 49-inch, that's the diagonal measurement of the display, up to an enormous 98-inch display. I'm not sure if there's many of those around. And there's 4 of the displays that are 80-inch or above. Yeah, so it's the 84-inch that we were using in the exhibition that I showed you just a few moments ago. Now, I do maintain a list of 3D TVs at the website I run called 3dmovielist.com, and I'll be updating it to include all of these as well there. So you're welcome to look at that site for a listing. So, as I've mentioned a few times already, 3D TVs are no longer available new in the consumer market, but with millions of 3D TVs sold into the consumer market, they do regularly show up in the secondhand market on sites such as eBay, Craigslist, or Gumtree. So you could potentially, if you're in the market for one of these displays, you can potentially put a search for those model numbers, and when they pop up, you'd receive an alert from eBay or whichever site you want to put the search into. Now, one complication is that our experience is that some passive 3D TVs have some level of misalignment or ghosting problems. Hence, it's important to test them for correct 3D performance. And a simple black and white test pattern can be used for that. The test pattern is a simple black on the top half of the screen and white on the bottom half of the screen. And when you switch the TV, when you send that to the TV, and switch it into over-under 3D TV mode, on a passive 3D display, the TV will convert this to a row interleave format. So we've got alternate rows being left and right eye. And when you wear the 3D glasses, as we can see here, the left eye, in the perfect world, the right eye will be seeing black and the left eye would be seeing white, or vice versa if you swap the two around. In the real world, no 3D display is perfect, and you will invariably get some form of crosstalk in most displays. And this illustrates the little bit of crosstalk that's occurring on one of the displays that I've got at Curtin. And so you can see a little bit of banding there, but it's very low, and the bright eye is very bright. However, some displays unfortunately exhibit a fair amount of crosstalk. Here is one display that we tested, and it had quite a lot of leakage or ghosting in certain parts of the display. So in the bottom part of the display here and the top part of the display. And this is caused by poor alignment or poor manufacture of that film patterned retarder layer. And it's poor alignment of those polarization strips with the LCD pixels. Now, if we raise the viewing position, we notice that the ghosting changes. And that's confirmation that it is misalignment of the FPR with the pixels. The fact that the crosstalk position moves when you change your vertical viewing position. So it moved from the bottom up to the top, and you can actually see it move as you move up and down. Now, unfortunately, this cannot be repaired. It cannot be fixed. It's the plastic polarizer layer which has been bonded. It's not just possible to just shift it around. As much would be nice to be able to do that. It's important that the TV is fine for 2D content, but it's not really usable for 3D unless you're only happy to use the small strip in the middle. So not all 3D TVs exhibit this problem. We've got two displays that perform really, really well, and of the 84-inch size. But it's wise to be wary of the problem amongst some of these displays. I'll just briefly mention too that Mike Weissman and myself published a paper in 2011 about a simple extinction test chart, and that could be used potentially to test this technique. However, this assumes that the crosstalk is the same across the whole display, whereas with these displays, usually the crosstalk is occurring in different parts of the display. So this test pattern would need to be adapted or modified to be able to measure crosstalk in different parts of the screen. But it just means moving the content around. One other point worth mentioning is that there are some passive polarized 3D TVs available to date, but they're just not marketed into the consumer market. They're intended for medical applications, including endoscopy. As a result, the price point for these displays is much higher than you would anticipate for a consumer display. You know, they probably lack some of the smart TV functions that many people are used to seeing as well. So in conclusion, although 3D TVs are no longer available in the new consumer market, many millions of 3D TVs remain available in the second-hand market. 4K passive 3D TVs are a good proposition, but unfortunately some have misalignment problems. So it's important to test them before trying to use them. That's the end of my presentation. Thank you for your attention, and if you have any questions, happy to answer them.